Welcome to Basic Statistics for Manufacturing, a short, distinctive co-curricular micro-credential course. This course, along with other high-impact experiences like it, are an opportunity for you to intentionally personalize your education, to build on the foundation of your academic program, and to accelerate your personal and professional experience. When you complete this course, you will have a distinctive employer-valued credential to add to your personal portfolio, a validation of your knowledge in manufacturing statistics. The three primary outcomes of this course will enable you to explain basic statistics and probability principles, to apply statistical methods to manufacturing problems, and to analyze and interpret results to make data-driven decisions. There will be other intermediate outcomes as we go through the various modules in this course, but these are the core objectives. Being able to explain basic principles ensures our understanding, which will be tested along the way with brief knowledge checks. But we don't want to just have knowledge without application, so we'll seek to introduce every topic with a relevant manufacturing problem or case study. Perhaps the single most important word in our outcomes is the last one: decisions. We'll always try to keep our focus on data-driven decision-making as our primary purpose. This course can be thought of as Statistics 101, an introductory treatment of stats with an emphasis on manufacturing. A foundational concept is that statistics are tools to help us make confident decisions, especially when we have limited information. The type of decisions impacted is broad. Decisions might involve operations, budgetary, or planning issues, or we might need to make a decision about process control or quality assurance or production timelines, or any other range of problems we might face, whether in a manufacturing environment or elsewhere. Fundamentally, statistics is a discipline that involves analysis of data, its collection, organization, and presentation. We use statistics to transform raw data into meaningful information which can be interpreted for intelligent decision-making. A statistic itself is a quantity, a metric, a measure that is computed from values, typically from a sample of data. The statistic may describe an important quality of the data, such as its range, or level of variation, or central tendency. And we also use statistics formally in evaluation of critical thresholds for hypothesis testing. Hypothesis testing is a systematic way of evaluating our belief about a topic, or how significant or insignificant a result is. Averages and means are common statistics that most people are aware of. They do describe data's central tendencies. But there are other similar statistics such as mode and median that might be used, depending on the specific context and use. The count of something is even a simple statistic that is used in many basic industry applications. Statistics and probability topics naturally relate. Probability topics concern numerical descriptions of how likely events occur. Sometimes the term probability is used more loosely, perhaps to refer to the degree of belief that an event will occur, or even as a metric. More formally, the probability of an event is a number between 0 and 1 that indicates how likely the event is to occur, where 0 indicates impossibility and 1 indicates certainty. Of course, higher probability means an event is more likely. Probability relates to the frequency distribution of data, often depicted in a histogram chart like the bar chart pictured here, or described by a probability density function, which we'll use quite a bit in our analysis. Later on, we'll look at the laws of probability. Because this micro-credential course is focused on helping you gain industry-relevant knowledge, we'll keep the topics focused on manufacturing. In particular, we'll aim to deal only with the practical measurement applications of basic stats useful for decision-making in industry. We'll do our best to employ only commonly accepted industry terms and to avoid theoretical topics. The intended audience of this course is engineering undergraduates. Our course structure includes an introduction, case study, central tendency and dispersion statistics, and measurement-focused statistics with applications such as dimensional measurement statistics. We'll also cover regression, probability, and hypothesis testing. Practical example problems and knowledge checks will occur throughout. Note that this course outline is distinct from a general undergraduate statistics course following the table of contents of a traditional textbook. We value such courses and encourage students to take a semester-long statistics course if possible. But we can't possibly cover every topic in a short co-curricular course like this, so there will be some gaps in coverage. Hopefully this course will provide broad exposure to common topics and motivate the interested student to understand why the application of statistics in the real world can be so beneficial. Mindset matters. Before diving into statistics, it's important to discuss trends in industry, more specifically the manufacturing industry. Hopefully this will help establish the intrinsic value of why it matters. We'll start with a recent report titled Future of Manufacturing: New Workflows, Roles, and Skills to Achieve Industry 4.0 Business Outcomes by Christina Bitelli as part of an ASME Autodesk collaboration. A link to the paper is provided on the course website. According to the report, the manufacturing industry faces a confluence of changes that will significantly transform the roles, skills, and workflows of engineers over the next decade. These changes are driven primarily by pressures on businesses to achieve outcomes related to improved computer-aided design, computer-aided manufacturing, productivity, output, profitability, reduced cost, competitiveness, and sustainability. Success depends on developing new manufacturing education pedagogies to effectively train the necessary Industry 4.0 technologies and skills. Some of the important skill categories highlighted by the ASME Autodesk report include technical and hard skills, such as artificial intelligence, machine learning, programming, visualization, and data analysis. Soft skills such as collaboration, communication, and problem solving, and more interdisciplinary skills like systems engineering, automation, sustainability, supply chain management, and product lifecycle management. Some examples of emerging industry technologies mentioned in the report include design for manufacturing, operations technology infrastructure, AI, ML-driven technologies like generative design, cloud-based software platforms like integrated CAD/CAM, project lifecycle management, manufacturing execution systems, business intelligence solutions, and centralized and cloud data management for collaboration and data analysis. With the adoption of IoT and other Industry 4.0 technologies, large volumes of operational data will be available. Engineers will need the tools and skills to extract meaningful information and insights from the data. Of 171 mechanical and manufacturing engineers surveyed in this report, 69% think mechanical engineers will need data analysis and visualization skills in their core skill set. Some programming, particularly low-code or no-code methodologies knowledge, will also be needed to identify areas to optimize and automate. In order to drive performance, profitability, and production, engineers will increasingly rely on massive streams of data to inform their decisions. Basic understandings of how to analyze, interpret, and transform data is critical. Think statistics. Industry 4.0, also known as the Fourth Industrial Revolution, is a new era of manufacturing that is characterized by the use of cyber-physical systems, the Internet of Things, and big data analytics. These technologies are enabling manufacturers to connect machines, devices, and people in real time, which is leading to more efficient and flexible production processes. Cyber-physical systems are physical devices that are embedded with sensors, software, and network connectivity, and this allows them to collect data, communicate with other devices, and make decisions without human intervention. The Internet of Things refers to the network of physical devices that are connected to the Internet. These devices can also collect and share data about their environment, which can be used to improve efficiency, productivity, and decision making. Big data analytics generally refers to the use of large data sets to identify trends, patterns, and relationships. This data can be used to improve product design, manufacturing process, or even customer service. Though Industry 4.0 is still in its early stages, it has the potential to revolutionize manufacturing. By embracing these new Industry 4.0 technologies, manufacturers have significant opportunities to improve operations, reduce costs, and create new products and new services. At the highest level, manufacturing statistics are used to track performance of manufacturing systems. Statistics help decision makers set goals, monitor progress towards goals, and drive improvements. Some common manufacturing statistics are output, backlog, throughput, inventory, yield, waste, cost, and cycle time, also known as span. Note that some key statistics like output, backlog, throughput, and inventory simply require count, the simplest statistic of all, just the total number of items. For example, inventory is the amount of items on hand, and backlog is the number of orders not yet filled. A high backlog might be a good indicator of demand, but it also might be a sign of a process bottleneck or inefficiency. Other statistics like yield and waste use percentage, which is also a simple way of normalizing count relative to a total or some reference value. Waste materials and products, especially those that have been rejected by quality assurance and scrapped, are other signs of inefficiency and areas targeted for improvement. Of course, time equals money, so total cost and cycle time are also key statistics, and they require very little math or theory to understand. To summarize, by tracking basic manufacturing statistics, Industry 4.0 ready manufacturers can make better choices about how to allocate resources, set prices, and improve operations. By identifying areas where improvement is needed, manufacturers can make their operations more efficient and reduce costs. By tracking quality metrics, manufacturers can identify and address problems early on, preventing them from causing costly defects. And by meeting customer expectations for quality, delivery, and price, manufacturers can improve customer satisfaction and loyalty. So the overall main benefits of using manufacturing statistics are the key drivers for why a course on basic statistics is important. Manufacturing statistics allow an increase in efficiency, quality, customer satisfaction, profitability, and ultimately improved decision making.